Hello, we are the group 4 and we will explain to you guys the Rutherford's model. So here it goes.
Rutherford model. The Rutherford model is a model of the atom device by Ernest Rutherford. Rutherford directed the famous Geiger-Marsden experiment in 1909, which suggested, upon Rutherford's 1911 analysis, that J.G. Thomson's plum pudding model of the atom was incorrect. Rutherford's new model for the atom, based on the experimental results, contained the new features of a relatively high central charge concentrated into a very small volume in comparison to the rest of the atom, and with the central volume also containing the bulk of the atomic mass of the atom. This region would be known as the nucleus of the atom.
Experimental basis for the model. Rutherford overturned Thomson's model in 1911 with his well-known gold foil experiment in which he demonstrated that the atom has a tiny and heavy nucleus. Rutherford decided the experiment to use the alpha particles emitted by a radioactive element as probes to the unseen world of atomic structure. If Thomson was correct, the beam would go straight through the good foil. Most of the beams went through the foil, but a few were reflected. Rutherford presented his own physical model for subatomic structure as in interpretation for the unexpected experimental results. In each atom is made up of a central change. This is the modern atomic nucleus. Though Rutherford did not use the term nucleus in his paper, surrounded by a cloud of presumably obtaining electrons. In this May 1911 paper, Rutherford only committed himself to a small central region of very high positive or negative charge in the atom.
Setting considerations of how far particles of no speed would be able to penetrate toward a central change of 100 electrons. Rutherford was able to calculate that the radius of his gold central charge would need to be less than 3.4 times 10 raised to the power of 14 meters. This small gold atom, known to be 10 raised to the power of negative 10 meters or so in radius. A very surprising finding as it implied a strong central charge less than 100 to 38,000 of the diameter of the atom. The Rutherford model serves to concentrate a great deal of the atom's charge and mass in a very small form, but didn't attribute any structure to the remaining electrons in the remaining atomic mass. It did mention the atomic model of Hansaro Nagauka, in which the electrons are arranged in one or more rings. The specific metaphorical structure of the stable ring was cited. The plum body model of John J.J. Thomson also had rings to orbiting electrons. Jean-Baptiste Perrin claimed on his Nobel lecture that he was the first one to suggest the model in his paper dated in 1901.
Rutherford's model to modern science. After Rutherford's discovery, scientists started to realize that the atom is not ultimately a single particle, but it's made up of a far smaller subatomic particles. Subsequent research determined the exact atomic structure which led to Rutherford's gold foil experiment. Scientists eventually discovered that the atom has a positively charged nucleus in the center with a radius of about 1.2 times 10 to the power of negative 5 meters times 1/3. Electrons were found to be even smaller. Later, scientists found the expected number of electrons, the same as the atomic number in an atom by using X-rays. When an X-ray passes through an atom, some of it is scattered while the rest passes through the atom.
Rutherford's model differed to the idea of many electrons in rings per Nagauka. However, once Niels Bohr modified this view into a picture of just a few planet-like electrons or light atoms, the Rutherford-Bohr model caught the imagination of the public. It has since continually been used as a symbol for atoms and even for atomic energy, even though this is more properly considered nuclear energy. Examples of its use over the past century include but are not limited to the logo of the United States Atomic Energy Commission, which is in part responsible for its later usage in relation to nuclear fission technology in particular. The flag of the International Atomic Energy Agency